So, I've played a fair amount of Jailbreak on my 5 years of playing Roblox, and one of my favorite features has gotta be the exploding wall. I mean, I could do this thing all day long. So satisfying watching it explode. However, I'll today be showing you how to create this for your own games. The first thing you're going to want to do is actually create your wall. I'm just going to make this one a little big and going to change the brick color to some dark red and the material to the brick material. So we just find that, and there we go. We got a brick wall. But now it's time to actually program this thing. So I'll create a folder which will house all of the walls I want to explode, just in case you're planning on making a lot of these. So I'll call this exploding walls, and I'm going to name this explode part. I'm going to put it in my folder. Now I'm going to create proximity prompt. Proximity prompt is kind of like a billboard GUI. So it's a 3D UI element which is assigned a key, and when that key is pressed for a certain amount of time, it'll trigger some event. The only properties I'm really going to tweak with the proximity prompt is the hold duration. I'm going to change it to 3 seconds. Now this object text is basically what text displays when the proximity prompt is shown, and I'll just change that to explode. Now you have to create a new local script inside of the starter GUI, and I'm going to name this client explode, and I'm going to take this proximity prompt that we made up here, drag it down into the client explode script. The first thing I'm going to do is create a little template for this script, and I'm going to start with services, variables, and connections. Now I'd like to note that these aren't entirely necessary, it's just a good way to structure your code. So we're going to need the replicated storage and the player service. Remember to always get every service at the beginning of your code and get it with the get service function, because some services are named differently in the Explorer than the actual name itself that's given through this function. This basically deletes any spaces and things like that. And then I'm going to create a couple variables for the walls, which we defined up here. So I'll do workspace, wait for a child, exploding walls, get children. And get children is basically just going to find all of the parts within this folder. Then I want to get the player, which on the client is players.localPlayer. I'm also going to define the proximity prompt that we put in the script so we could duplicate it and put it in each one of the walls automatically. So that's going to be script.proximityPrompt. And this script thing right here is just referring to this script object that we're working in currently. So now, if we go to connections, and we just do for underscore part in pairs walls, which means we will execute this code for every wall is in the folder, and we'll do local new prompt equals prompt clone, which is going to create a duplicate of that one, and then we're going to parent it to this part. There is an event of the prompt which is called triggered, and this is when that key is pressed for a certain amount of time. So now we're going to want to know if the player is actually alive. So we'll do player.character.humanoid.health is less than or equal to 0, then return. This basically just means it's dead because its health is less than or equal to 0. Now, what we're going to want to do is we can actually explode this wall on the client, or else it won't happen globally on the server. So we'll go to replicated storage, click the plus icon, and create a new remote event. I'm going to call this one explode wall. So that's where the replicated storage comes in. I'm going to do local explode remote equals replicated storage, wait for a child, explode wall. Now all we have to do is explode remote fire server part. Now I'm going to go to server script service and create a new script. And this is how we're going to connect to that event being fired from the client. I'm going to call this script destruction. Remember, you don't have to name your scripts the same thing as I do because names of scripts don't really matter. I'm going to do what I did in that local script template. Services, variables, functions, and connections. Spelled that wrong. And there we go. So we're of course going to want replicated storage. So we're going to want to define some number variables here. We're going to have max activation distance. And we're going to use this for a little sanity check. So we know that they should be able to destroy the wall. And we're using 10 here for a reason, and that's because when we go down back into this proximity prompt, we realize that max activation distance here is 10. So just make sure that this variable is lining up with this one down here. Now I'm going to have the destruction duration, that's going to be 5. And the destruction duration is just going to be how long the wall is out of view. And the RNG favoring, which is going to be 1. I'll get into what that variable does later on in the code. Now we're of course going to want to refer to that event and the walls folder. So we'll get local explode remote equals replicated storage, wait for child, explode, what's the name, explode wall, and local walls equals workspace, wait for child, exploding walls. Now I'm gonna skip functions because that'll come along later, and I'm just gonna do explode remote on server event connect function player part. And this right here is just making it so when that event was fired from that client script, something is going to happen on the server. So the first thing we have to do is actually do some sanity checks to make sure that they can fire this. First sanity check I want to know is if this part is supposed to be exploded. So we're going to do local character equals player.character. And if character is equal to nil, meaning that they don't have a character right now, or the type of the part doesn't equal instance, or the part is not a descendant of the exploding walls folder, then we're going to deny the request. So is descendant of walls, then return. So I'm going to break down this line right here because a lot of things happen in this one. So type of is basically going to check what type of variable we're dealing with. So there's a bunch of different types: strings, numbers, enums, and things like parts and all the things that you see in your Explorer are instances. So this is going to ignore things like strings and numbers because that's going to cause an error in the code. So now I want to know if they're live. So we're going to do local humanoid equals character dot humanoid. If humanoid, actually, we also fit the root part in here as well. Character dot humanoid root part. We're gonna do local distance equals root part dot position minus part dot position dot magnitude. And this basically right here is measuring the distance between these 2 points, the player's position and the exploding wall's position. So we're going to do if math.floor distance. I'm going to floor it because just in case of some server client latency, stuff like that, I'm going to do if math.floor distance is greater than max activation distance, or humanoid.health is less than or equal to 0, then return as well, because they're not alive and they're not close enough. Now it's time to actually make the explosion. Now, with a couple particles in the Roblox engine, they're already pre-made, such as smoke, fire, sparkles, and of course explosions. So the explosion is just going to be the effect that we're using. So now we're going to create an explosion by doing local explosion equals instance.new explosion dot parent equals workspace explosion dot position equals part dot position. Now, just like parts and spawn locations, mesh parts, stuff like that, explosion also has to be positioned, or else it's just going to be at point 0. Now I have this other thing called destroy joint radius %, and I'm gonna set that to 0. And this is something that actually damages people when they're in the blast radius of an explosion, and we don't want them to get damaged. We're also going to change the blast radius to 0 and the blast pressure to 0 as well, so it doesn't damage people and it's not kicking around unanchored parts. Lastly, for this part, we're going to set its explosion type to enum.explosionType.no creators, because if you're using terrain instead of parts, like in Jailbreak for your flooring, then it's going to destroy some of it, and we don't want that to happen. I'm just going to conduct a short play test so that we know that everything we've done leading up to this point actually works, and we can debug some errors. So as you can see, our proximity prompt is showing. Now we're just going to use it and see if an explosion pops up. And there we go. There's an explosion. But we're not quite done, because we want this wall to crumble and fall apart. Now, this part is actually going to require a little bit of math. I won't be explaining it fully, but just explaining how certain parts work. Now, the first thing we're going to do is, since we're splitting this into segments, we want to know which properties from the original wall we want to keep. So we're going to do local copy properties is equal to a table. And in this table, we're just going to have a bunch of strings. Now, when we go to our explode part and we go down to the properties, we can see all these labeled under appearance. And these are all the properties that we're going to want to copy. So we're going to put cast, shadow. I'm not going to put brick color in here because it's a little bit less accurate than color property. Just putting that out there. Cast, shadow, color. remember to spell these correctly. Material, reflectance, and of course transparency. Now we're going to make a function that will make a new part that's copied all these properties. So local make new part, in the original part, local function I meant to say, so that we know we're making a function, and we're going to do local new part equals instance.new part, and then we're going to do for underscore property in pairs copy properties, do new part property equals part property, which is going to make these properties from the original wall go into our new part. And we're going to do new part dot parent equals workspace, and new part dot, return new part, so that we get the new part upon calling it. And now is the actual mathematical part. So we're gonna first do local rate, actually local size equals part dot size, because we want to make the amount of parts that fall from this to be somewhat relative to the part's original size. So, we can break it down into little parts. And then we're going to do local x, y, z equals size.x, size.y, size.z. This is just referring to all axes of the size on the wall. Now we're going to want the rate at which the parts fall, so local rate, which I'm going to set to x plus y over 2. And now we're actually going to want the bottom right corner of the part, so we're basically going to be turning this into a grid, and to do that we're going to make it kind of like a coordinate plane by finding a corner, which is going to be our position 0, and then working down the grid. So local corner equals part.cframe times cframe.new negative x divided by 2 0 0 dot position, and then that will actually only get the right side of our part, but finding the bottom right is as simple as just subtracting a little bit here, 0 y divided by 2 0. Now we're going to iterate through a couple of numbers. So to begin, we're going to do local parts is equal to table, and we're going to store every mini part that makes up this big part in this table, so it can later be destroyed. And I'm going to do for y, capital Y, so it differentiates itself from our lowercase y, since variables are not very caps sensitive. So I'm going to do 0 math.floor rate do for I equals 1 y do. And this is just going to make it so that we're copying parts on both the x and y axis to make our cubes make up kind of like a two-dimensional grid onto our three-dimensional part. So now we're going to make the new part. So we're going to do local part equals make new part. This variable is basically going to override the old part since we don't need it right here. And I'm going to do a little bit above here, local pose equals vector3.new I y 0, and that's going to be the position of the part on the grid. I'm going to do part.position equals pose, part.size equals vector3.new x divided by rate, y divided by rate, z, and that's just going to size it accordingly to its spot in the grid, so that each grid slot, just like a coordinate plane, has its own size. And part.massless equals true. And this basically just gonna make it so the physical mass property doesn't actually apply to this part. And then I'm going to insert it into our parts folder. Now, basically we're creating a lot of parts on top of this old one, so we're gonna want to parent our original part to nil so that we can get it back later, because we don't want to destroy it, but we also don't want it to be visible. And we could simply do that by changing transparency to 1, but then the proximity prompt will still be there, and I don't really think that'd look very clean, would it? So now I'm going to call the delay function and have the explosion, the destruction duration, and then part.parent equals walls. We are also going to want to loop through this our parts table and destroy all the old parts that made up that grid. So part destroy. And now, just to make sure that everything is working correctly, we're going to go in and test it out. And it looks like something went wrong. However, our parts are still showing up to some extent. However, I think I know what I did wrong. So, right here, we're only finding this point on the grid, but you aren't making it relative to the part's original position. So we have to do corner plus vector3 at new iy0. And that should actually make it work. So I'm going to go back in, just to see if it works. And wait for this to happen. And as you can see, they all appear. However, it takes a lot of work to get them to kind of crumble down. So I figured while making this that the best way to make it fall down is kind of make it like an unstable game of Jenga, if you're following me there. So I'm going to do if math.random 1, 2 is equal to RNG favoring, doesn't equal RNG favoring, then continue to the next index. And this is going to make it so it skips certain parts, so that if one part has one that there's no bottom piece to it, then that one's going to fall. It's going to create this chain reaction that will actually make the wall collapse. So, I'm going to go back in and see how it works. And as you can see, it falls down and crumbles just like you should. So that's the end of this video. If you enjoyed it, remember to like and subscribe, and I'll see you in the next one.